Good afternoon, everyone. Welcome to our live stream from McDonald Observatory. My name is Joe Wheelock, and Judy Meyer is co-hosting today. So glad to have all of you join the stream today. Unfortunately, we have some pretty cloudy skies today, rain in the area, so we won't be able to get any live views of the sun. But we have some backup programs planned just in case of that. So, Judy, you want to introduce yourself?
Hello, I'm Judy Meyer. I work here at McDonald Observatory. I've been here a really long time, and I do all kinds of different things, including programs for people and programs for, not that they're not people, students and teachers, and I'm very happy to be here. And we're going to talk about the sun and solar maximum today. So, shall we start by talking about what solar maximum is?
Sure.
Well, let's get my slides in here.
Yeah.
So, people have been looking at the sun for a very long while, and it looks to me like this is 400 years worth or more, and it wasn't until the mid-1700s that people started really observing the sun and counting sunspots. And so that's what the blue line is. But there were observations made before that, and those are what the red marks are on there. And then the black line is kind of an average, sort of a smoothed out curve, and you can tell that the average amount of solar activity has changed over time, which I think is very cool to see, and it's very interesting to see what's going on with it right now. And I like looking at graphs and curves, and this is pretty interesting. What do you think of this one, Joe?
I like that one. It's kind of interesting to see the different peaks and valleys of what's been happening on the sun over the last 400 years. I noticed this big spike around early 1950s, and also back around what looks like about maybe 1775 or so too. It's pretty interesting.
And I really like this, how the graph is going upwards right at the end. And it looks to me, I've seen predictions that we're going to hit solar maximum in 2025. Have you heard that, Joe?
2024, 2025.
Okay. Well,
give or take a year.
It's not either of those years yet. And
right.
So we've still got a ways to go. And so I expect this round of solar maximum to be more energetic, more activity than the last one. And so those of us who, we don't have to keep a satellite safe or worry about solar activity damaging and destroying things, we think solar activity is cool. So I'm excited for a big active solar maximum. How about you, Joe?
Yeah, really excited. It's been kind of a long time coming.
It has. So what we're going to talk about first is, I'm trying to advance my slides. We'll see if that works. Maybe it will. Maybe it won't. We'll see. Hopefully. Come on, slides. Do your thing. Okay.
Having trouble?
Just the usual. Hang on a
sec.
Well, yeah, I'm just clicking on the window and it's just saying, yeah, so what do you want?
There it is. Okay, there we go. Okay.
So here is a picture of a magnet. And I know we're supposed, oh, you know what I forgot to say. We have people watching live. You are welcome to chat in the chat, ask questions. We do have a moderator. It's our friend, Mr. Supernova, and he would love to answer questions about the sun or the weather or anything else. So feel free to chat in the chat. But back to the show. This is a picture of a magnet. And I know we're talking about the sun, but the main one of the main things that happens on the sun is that there are magnetic fields and there's magnetic activity. And so I think it's important to look at a magnet and know what we're talking about. And so this is a picture of a magnet that has been sprinkled with iron filings, and the iron has stuck to the poles of the magnet if it can, but the iron that's out away from the magnet is lining up in line with the magnetic field that exists around a bar magnet. And a magnetic field is a little bit like the wind, where you can't see the thing, but you can see what it does. So you cannot see a magnetic field, but you can see what it does. And it causes things that are susceptible to magnetic fields to line up with the magnetic field. So that's a picture of a magnet and iron filings. And there are not magnets or iron filings on the sun, but there are magnetic fields. And so here's a view of the sun. I took this picture off the Solar Dynamics Observatory website just from today. And so this is what the sun looks like today. And we can look at this and we can see that there are quite a few sunspots. There's one that's especially large and prominent in the lower right-hand quadrant of the sun. And then there are some smaller ones and some more that are sort of grouped together. And so there's quite a lot of activity on the sun today, and that's pretty cool looking. But how does that compare to magnets? Well, Solar Dynamics Observatory has a whole bunch of instruments available, and one of them can tell us what the magnetic field on the sun is doing. And so here, this view in black and white is showing you areas of a north magnetic pole and a south magnetic pole, basically. And so black versus white, north versus south, south versus north, I don't even know. But what you can see is we had that big sunspot in that area in the lower right-hand quadrant on the sun that has a very prominent dark magnetic field concentration. And then across the top where we saw those 4 spots in a row, you've got some other magnetic activity. In other places on the sun, it looks more or less neutral, right? So, ooh, cool. Somebody says they just got a view of that large spot with eclipse viewing glasses. What a good use for eclipse viewing glasses. That's wonderful. So that's the magnetic field on the sun, and that's kind of not very pretty, is it? So let's look at a prettier view of the sun. I just love this view from the Solar Dynamics Observatory website. And again, this is still from today. And so in the lower right-hand quadrant, what we're seeing is that we're seeing 3 very short wavelengths of light on the sun. And so it's not showing us the visible view of the sun. It's showing us other aspects of the sun. But if you look at this, maybe you can see that the gases, well, actually plasma on the sun is following these magnetic field loops. And so that's nice. That's fun to see. And we have a special lot of activity kind of across the top where we saw those 4 areas in a row, and then that lower right-hand quadrant. So the Solar Dynamics Observatory folks do us the very good favor of drawing in the magnetic field lines for us. So let's just look at that. And now, drawing in the magnetic field lines, what you can see is there are magnetic loops all over the sun. And those magnetic field lines are concentrating especially at that area that looks a little bit blue, kind of in the lower right-hand quadrant of the sun, right in here where I'm circling with my mouse. And then across, I would call this the eyebrow area of the sun. Just, if you were drawing a face on the sun, that would be where the eyebrows would be. And those are all places where we have seen sunspots. We know that sunspots are taking place there. And also, I just love how pretty these pictures are. So there's that nice view of the magnetic field on the sun. And how on earth can a magnetic field get all twisted up and weird like this? It's because of the way the sun rotates. And the sun, I hope you realize the sun is not a solid body. The sun is made of material that is gaseous in nature, and it's mainly plasma. So it's gases that have been excited. And so most of the gases are ionized. So if instead of a hydrogen atom, you have an electron over here and a proton over here, and moving an electric charge through space gives you a magnetic field. And here we're looking at just a diagram, a cartoon that shows you that the sun, when it rotates, and the sun does rotate, it rotates in different rates at different latitudes. That's not something a solid body like the Earth could do, but a body that is gaseous in nature is able to do that. And so the sun rotates faster at its equator and slower at its poles. And you can try doing that with your, I have tried that. You know, I stand up and I move my head a little slower, and I try to move my waist even faster. It doesn't work for a person, even if we're a little bit bendy. But anyway, so there's that. And then the sun, like the Earth, has an overall north to south magnetic field. So we can watch a north to south magnetic field line get wrapped around the sun as the sun spins faster at its equator than it does at its poles. And eventually, those magnetic field lines start getting bunched together, and they poke out of the sun. And those are those loops that we were seeing in that beautiful view of the magnetic field on the sun. After it's done that many times, the sun's magnetic field is quite complex and weird. So this picture shows 3 different views of the sun in 3 different years during and after a solar minimum. So 2010 was a solar minimum year. You can look at this image on the left and see that the magnetic field lines were nice and smooth and went from north to south, south to north, just the way you'd expect. 2013 was in the middle between solar minimum, and so it's got a complex magnetic field. And you can also look at that and see that the sun itself is looking more active. And then 2017, you're back to a more or less minimum magnetic field, nice and smooth magnetic field. And I don't remember if I have one more slide or not, so let's just see. Just back to this pretty view.
Back to that one.
Yeah. Yeah, and I think that's all I have until Joe talks about coronal mass ejections.
All right, thanks, Judy. So yeah, coronal mass ejections. That's a mouthful. We get to say CMEs for short. Yeah, these are clouds of energetic plasma that periodically erupt from the sun. In fact, there was a very recent big eruption on the sun, and let me share with you a video of that. I have it somewhere in my stash of slides. Give me a second here and I will find that. Here we are. It's taken by an orbiting spacecraft, and that black disk in the middle, that's creating an artificial eclipse of the sun. And you can see these eruptions coming here from it. And you also, if you're familiar with astronomy, you might notice a grouping of stars just above. It looks like it's getting zapped by that CME.
Hey, it looks like the world's tiniest dipper.
Right. Anybody know what that is? If you want to write it in the chat, what that might be. We'll give it a minute here. There could be a delay. Don't have a whole lot of people watching, but maybe somebody will respond. The Seven Sisters.
Excellent. M45 is another
M45.
name for it. Yeah.
Pleiades. Also another name for it is Subaru. Right. Just as I said that, somebody wrote it in the chat. So yeah, that's a really neat video there. So let me get rid of that. And I'm going to go to some more slides here that I have prepared. Figure out which ones we have here. Give me a second. I think it is that one. So we have these large eruptions that happen on the sun. And when these eruptions impact the upper atmosphere of the Earth, they can do many things. They can disrupt satellites, knock out cell phones, disrupt radio transmissions. And if you have a really large eruption, it could be devastating. In fact, there was one that happened in 1859. And the picture on the left, you can see a sunspot. It was drawn by an Englishman named Richard Carrington. Big
Okay.
sunspot grouping there.
Joe, that looks like a dragon.
It does look a bit like a dragon. Now that you mention it, yeah, it does look like a dragon. Yes, it does. Anyway, so about a month after he recorded this big sunspot, there was a large coronal mass ejection from the sun. And in fact, it caused displays of the northern lights, the aurora borealis, or the aurora australis, the southern lights, to be seen as, like as far south as perhaps the Caribbean or Hawaii. Yeah. In fact, people could, read by this. People thought that it was, it was so bright, the sky is so bright. People thought, the sun was coming up. And these disturbances actually caused telegraph wires to catch on fire. Yeah, kind of strange, kind of crazy. Now, more recently, there was an eruption that happened on March 13th of 1989, and that caused a power outage in Quebec and some other parts of the North America. And the picture here, that's not an actual photograph from space. You can see there, that's just an artist's impression of how it may have looked there. Now, these big eruptions like this don't happen very often. Maybe once every 500 years. So the chance of this happening, today would be vanishingly small, maybe a few percent. If it did happen, it could be devastating. So hopefully that will not happen in our lifetime. So let me go to my next slide here. And we already talked about that. I don't know why I have that in my slides. So
it's okay. It's a good.
All right. Very good. I just like that slide there. So, yeah, the modern minimum happened from 1645 to 1715, and some other, the Dalton minimum, and the modern maximum. So let's skip over that. And what I want to do now is talk to you about some ways to view the sun safely. The safest way is to project the image on a piece of white paper or a piece of white cardboard, as you can see in the picture with the little red telescope. Other safe methods are to use filters that fit on the very end of a telescope. We have glass filters, and we also have mylar filters. Now, the first telescope that I got when I was a kid, 10 years old, it came with a device like this called a sun filter. Yeah, what these are is a piece of welder's glass that kind of screws in on the end of an eyepiece. And the bad thing about these, the concentrated sunlight could cause this glass to heat up and crack. That could damage your vision. And a couple of years later, when I joined an astronomy club, a member of the club about the Evansville Astronomical Society, a shout out to them, he told me never use it, whack it with a hammer. That's what I did. Now I do admit, I did use it a couple of times and I got lucky. Yeah, so if you run into one of these, get rid of it. That's my advice. Now, if you want to view the sun without a telescope, there are some safe methods. Somebody mentioned in the chat they used eclipse glasses, perfectly safe without a telescope. Another way is to, you could use like a cracker with holes in it and project images of the sun on a piece of white paper. anything with holes in it, like maybe a strainer, or put your hands like this together, or the gaps in between your fingers could project a nice image of the sun. Yeah, so Judy has our little cat there with eyes for holes.
Yeah, I 3D printed this.
Okay, yeah.
The eyes are holes,
free,
and then when the sun is eclipsed, then the eye shape is the shape of a crescent, and it looks like a cat.
Mm-hmm.
Yeah.
That's interesting. So,
Yeah.
all right, so that's safe ways to view the sun. So let's see here. What do we have next? All right, so we had planned to view the sun today using our telescopes, two different types of light. We have, visible light, light that our eyes, of course, can detect. We can also study the sun in a type of light called hydrogen alpha light. This is a very narrow wavelength of light requiring a special filter to see features in this type of light. So let's see here. So our solar telescopes that we have here at the observatory, they're located in this structure called a roll-off roof observatory for obvious reasons. Then we have 3 telescopes here with solar viewing. The main telescope allows us close-up views of the sun in hydrogen alpha light. Then we have a couple of smaller telescopes on the side for wide angle views of the sun in visible and also in hydrogen alpha light. So since we cannot look at the sun today because of the weather, yep, it's still pretty cloudy. So what I'll do here, switch over to a picture. In fact, I think Judy already showed you this picture. Let me get rid of this here. Say goodbye to that. And we will, let's see, let's stop that completely. There we go. We're going to go to, where is it at here? Yeah, this one. That's what I thought. All right, so here's a picture of the sun. Latest picture taken from a website, spaceweather.com. And on that website, they update what's happening on the sun about every day, what else is happening in the sky. And we see a number of sunspots here in this picture. The big sunspot you can see toward the bottom, kind of bottom of the sun there, middle bottom. That's maybe 3 or 4 times or so the size of the Earth. Now the sunspots, they have a dark center called the umbra and a lighter outer area called the penumbra, Latin words meaning shadow. When people first looked at the sun, they thought they were shadows on the sun. So these were old names to have stuck with us throughout the ages. And you'll hear these terms, umbra and penumbra, later on during the program. So that's visible light. So let's take a look at the sun with another type of light called hydrogen alpha light that I mentioned. And that was, what was that one? That was this one here. All right. Hydrogen alpha light. This is taken from a telescope located in South America. And if you look at this picture carefully, study it, you will see things around, looks like what we call the limb of the sun. Around the limb of the sun here. Those are, there we go, my arrow popped up. Those are called solar prominences. And they have this kind of looping effect because they're following the magnetic field of the sun. When viewed face on, in fact, I can zoom in on this, that dark line, that is not a crack in the sun. That is one of these being viewed face on. Remember, the sun's up, a globe, so you have things that are coming at you. And we call those solar filaments that are that are just suspended above the atmosphere, the chromosphere of the sun. And we can see a number of sunspots in this close-up view. The brighter areas, that could be some solar flare activity trying to appear, perhaps. Now, some that aren't as energetic, they're called plage, like say maybe this one down here. A plage comes from a French word meaning beach. When people first looked at the sun, they thought there were, beaches and mountains on the sun. There aren't, of course. These are more old names that have stuck with us throughout the ages. Now, there's a fuzzy area around the sun here. We call that the spicule layer. These are rising jets of gas from the sun. To give you an idea of the scale of this, that spicule layer, if anybody thinks they might know how big that might be, pop that in the chat. That fuzzy area. Let's give it a second here. I know, Judy, you know, and I know. Let's see if anybody has a guess. Give it a second here. There's sometimes a delay.
About an Earth?
Deep Sky Dude says about an Earth. Let's see if we have anybody else that's guessing. I don't see. Give it a minute here. Don't see any more. Okay, well, in that case, it's about half of an Earth. About half the size of the Earth. So we can kind of, oh, I'm sorry, you missed the question. Okay. Yeah, the question was, how thick do you think this fuzzy area is here? That spicule layer. Sorry, you missed the question there. That's about half the size of the Earth. Answer to your question there. So, all right. So we can gauge how big, like that prominence there. So if you can see my little magnifying glass on the screen, that's maybe half the Earth. So this is probably, what do you think, Judy?
Your screen is very tiny for me, so
I know, right? I know it's very tiny. Yeah, I'm gonna say maybe. I don't know, perhaps 3 or 4 times the size of the Earth, perhaps. So that's the sun in hydrogen alpha light, which we could view with our telescopes, but unfortunately we can not. So I think I have.
So
Go
Joe,
ahead, Judy.
do you have an idea why that big sunspot is light colored right now? Is that just?
Yeah, I can tell you why. It's an effect of the camera they were using. What they did is they probably oversaturated that sunspot. So really, it should be dark.
Yeah.
So they just, for those that are familiar with photography, they kind of overdid the exposure, I guess you could say. Yeah. So that's what's happening today on the sun. Now these are taken by some ground-based. This is taken by ground-based telescopes. The one I showed you, the CME, a space-based telescope. Well, ground-based telescopes can get some amazing images. Let me find that here. Let's stop my screen and find my slides here. I'm going to show you a neat video. There we go. Let's see here. Where was that? That's not it. This is it. Here is a video of the sun taken with the world's largest solar telescope. And did I press start? There we go. Helps if you press start. Anyway, the video taken with the world's largest solar telescope located in Hawaii called Inouye. It's a 4-meter telescope. Now, this the little cycle of the sun looks like kind of bubble wrap caused by convection currents in the sun. And these are called granules. Each of the granules, they're about the size of Texas. They behave kind of like a pot of boiling water. The next, we're going to see an extreme close-up view of these individual granules. So I really found that a really amazing video there. So that's really all I have for you about the sun today to talk about it. Wish we could see live views today, but let's see here. Let's turn it back over to Judy to talk about some other things here.
Well, Sally just said that she viewed the last eclipse from
under trees. Okay.
And each spot
That's
of light filtered through the trees showed the eclipse. And I did that when I was in graduate school, actually. Mm-hmm. And it was wonderful. It was beautiful. And it was so interesting because there was a little breeze. And I was walking down the sidewalk, and this dappled sunlight on the sidewalk, I realized was little crescents that were just kind of moving in the breeze. It was sort of strange and sort of wonderful.
Judy, don't you have some other devices that can help you view the sun safely? You said.
Oh my goodness! Don't I have some other devices?
Yeah.
Yes. Hang on. I have eclipse glasses.
Yes, we all have those.
I also have eclipse viewers, and one of the things that we're encouraging people to use, especially if you have little people in your family, with eclipses, is an eclipse viewer, just because it's harder to keep the glasses on a kid, and you can say this is a window to look at the sun through. Maybe that would work better, and then in the ultimate case for that, glue either the glasses or the viewers onto a hole in a paper plate, and then the plate can cover the face, and the kid's whole face is protected while they're looking through a safe window. So it's very important, if you're going to use glasses or viewers, to buy them from a reputable source. And we have our own eclipse website that I do not have the web address in my head, but at our McDonaldObservatory.org website, it's under the Learn tab. And you should all go there and learn about eclipses. So we have eclipse viewers like that. We have the kitty pinhole viewers. And then I've been collecting cereal boxes. Oh, this is fun with a green screen. Oh.
Yeah, it's kind of transparent.
Hold on. Let me
That's interesting.
Because I didn't think it knew I didn't have a green screen. I'll turn that off. All right, that should work better. Okay, so am I back?
You're back. You froze up for a second.
No, I am not supposed to be there. This is our visitor center, and I'm not there. So that's just funny.
The weather's better in that picture, too.
The weather's way better than it actually is, yeah. Yes, technology and I are not being friends today. All right. All that to show you a Cheerios box. We're collecting cereal boxes, and what you can do with a cereal box is cut 2 holes in the top, and somebody suggests putting a piece of white paper down in the bottom. I'm like, I don't have time for that. But then I fit one side with a piece of foil that has a little hole poked into it. I'm not sure you can see the hole, but there's a hole. And then if I look into the box with the sun at my back, sunshine can shine into the hole and it will project an image of the sun in the bottom of the box. It's a safe way of viewing the sun because I'm looking away from the sun, right? And the sun, I'm not even facing towards the sun. So I really like a pinhole viewer that lets you look away from the sun. I like that a lot. And so we're doing cereal boxes. What else do I have? I think that's all I have right here. But I'm sure there will be more as time goes on. Oh, good. You can see the hole. Good. All right. So those are some ways of observing the sun. Anytime, but the sun is going to look like a disc in a cereal box pinhole viewer. You probably are not going to be able to see sunspots with that. Joe, would it be possible to pull up your slide that shows the astroscan projecting?
Yes, I can. Give me a minute here and let me find that. I have so many slides.
Joe of the mini slides, yes.
Yeah, I told Judy earlier, I have a cornucopia of slides.
A cornucopia. Well, we're waiting. Right behind me, there's a picture of the sun, and it's dimensional. Well, it's not, it's 54.5 inches across side to side. And then the little dots that go across the midsection of the sun, those are the scaled size of the Earth. They're half-inch blue dots. So here is Joe's slide that shows safe ways of observing the sun. And that red telescope is an astroscan that are no longer available. They're no longer being made. It turns out the mold broke and they decided not to fix it. So if you want an astroscan telescope, you got to find one on eBay or somewhere, but they're really nice, portable, small reflecting telescopes. And Joe and I both use these with school groups that come to visit us, and we allow them to observe the sun doing this. And with a projection like what you see there, you can see sunspots, which is very awesome. And if it were during an eclipse, you would see the sun becoming more and more eclipsed. So yeah, try the cereal box. It's pretty cool. So we're going to talk about eclipses. And now that we've looked at the safe solar viewing again, because like Will says, safety is number one. But let's talk about solar eclipses a little more. And
let me get those slides here.
We're gonna do this coordinated thing where Joe does the slides and I do the talking. So hang on to fasten your seatbelt.
Hang on to that.
Right. Okay. Wonderful. I really like this. This is a cool slide that it's just showing you what a solar eclipse is, and it's when the moon and the sun are in line with the Earth, and the sun casts the shadow of the moon onto the Earth. And the cool thing is that 2 solar eclipses are crossing Texas within the next year. And one of them is the annular solar eclipse that's happening October 14th, which is a Saturday. So no excuses to miss that one unless that you have work day on Saturday. But an annular eclipse just means the moon is a little farther from the Earth, and so the moon's disk doesn't totally cover up the sun. And if you are in the path of the annular eclipse, you may see something that we call the ring of fire, like that left-hand view on the slide. And then April 8th, it's a total eclipse that also crosses Texas. And during the total eclipse, the moon is close enough to the Earth that its disk totally covers the sun. And that is the only time that it's safe to look straight at the sun without any kind of safety aid, like eclipse glasses or something. It's the only time, and you got to be careful that you're not still watching it when the eclipse ends. What's your next slide, Joe?
Well, you don't have to be in Texas to see these eclipses, Judy.
You don't. But
no,
Texas
you don't.
is the best place.
Yeah.
See, the El Dorado Star Party falls on the center line for the eclipse. And where's that?
Near El Dorado.
Yeah, I guess so. So you can see these two paths crossing the US and Texas gets a partial eclipse for everything, for both of those events. And McDonald Observatory, of course, is not on the line for either of those. But we're doing a lot of eclipse outreach. We have an eclipse page. Oh, okay, near Sonora. That's awesome. That sounds like
Oh, here we go.
a wonderful place to go to see an annular eclipse. Although, if I had to choose, I'd go to Corpus Christi. I volunteered to go there, and I don't think anybody at work is going to take me up on it. Anyway, so here's our map that shows those two eclipse paths. And do you have another slide, Joe?
Yes, I do. I want to mention something. Yeah, I want to mention something. The total eclipse. If you can see a total eclipse, even a total, definitely definitely go see it somewhere.
Do it. Yeah.
Definitely make the drive. I saw the one in 2017, and it's kind of a life-altering experience. And here's something ironic for me. The April the 8th eclipse next year, it actually, I grew up in Indiana, southern Indiana, and it passes through the backyard of my old house.
Way up there.
Yeah, way up there. So, but yeah,
right
if you're
under
in
the
Texas,
two somewhere, right? In 2024.
Pardon me?
In the 2 in 2024. No, the R
actually, where the R is solar eclipse.
I don't know it. Indiana from.
That's all right. Yeah. So anyway, yeah, if you're in Texas though, here we have a detailed map that shows you, I guess if you're right in the middle here in this spot right there, whoops, I don't want to advance that slide. Let's go back to this slide. If you're in that middle spot, that's the sweet spot there. Yeah.
Yeah.
So yeah, and that's and unfortunately here at McDonald, we're going to miss both of those.
No, we get partial eclipses for both.
We'll miss. Yeah, we'll see it, and they'll be partial, but we won't be in the path of annularity or in totality. Now, the total eclipse in 2024, it's going to be a long eclipse. In some cases, 4.5 minutes long. And the one that I saw in 2017 was only 2.5 minutes.
Yeah.
So that time goes by very fast.
And when is the next total eclipse going to be in the U.S.?
Oh, if you miss these two, if you miss next year's, you'll have to wait until August, I believe, 2045.
Goodness.
For a good one. I think there might be one a little earlier that's going to kind of scrape maybe part of the U.S., but that one's going to go kind of through the middle of the country. So it'll be a bit. So try to get this one next year.
Yes. So I want to share a couple more slides here because we're approaching solar maximum and there's going to be a total solar eclipse. And these pictures were taken by the SOHO spacecraft that has taking images of the sun and over as we're approaching a solar maximum. And what you can see is during solar minimum, the sun is kind of boring looking, and the sun's corona is a little bit boring looking too. And as you approach solar maximum, both the sun gets more interesting just because there's activity on it, and the corona gets brighter and more interesting. So that's the map slide is available. Links to the map slide is available on our eclipse website, but it's if you type in to a search engine, Great American Eclipses, those maps are there, and they're available for purchase. And we use them with permission because we're doing education. So I want to show you, somebody did an actual study and took images of eclipsed suns, coronas, during different times of the solar cycle. And if you look at the image on the lower left, this is during solar minimum. And during solar minimum, remember, the sun's magnetic field, oh, we're back to the magnetic field, is really nicely organized, smooth and straight, and you're not seeing a lot of activity on the sun. And in this lower left-hand view, the corona is nicely organized, smooth and straight. If you just make those lines and say those are probably along with magnetic field lines, it makes perfect sense to me. And then in the upper left, you have a view of a corona during an eclipse that happened during solar maximum. And you can see that the corona is way less organized. It's got lots more things going on it. And so I find this a really great confirmation of my idea that our next eclipse is going to be very interesting and really fun to look at the corona during the April 2024 solar eclipse. So that's basically all I want to say about the sun and eclipses. Is solar maximum is coming along with a total solar eclipse. So figure out how to take pictures of the sun during an eclipse. And
can I mention something, Judy?
Yes.
When you're viewing a total solar eclipse, not only, will of course the sky darken and you might see, planets or stars out. Observe the effect it has on animals. When I was watching the eclipse in 2017, we were near a small pond and we could hear frogs chirping and birds were acting funny and other animals could behave strangely, thinking that it's, hey, the sun's going down. I should start thinking about going to bed. So yeah, it can have effect on animals.
Yeah.
Oh, bug right here. It just flew past me. So what else do we have, Judy?
Hold on.
Okay.
I think we're done. I think we've hit all the things that we wanted to talk about. So now is a great time to ask questions. I am going to toss in the link to our eclipse website, and it has lots of links on it and information and links to sign up for a newsletter, etc. So lots of other things, and I will just throw that on the screen as well. I was going to throw that on the screen. There you go. Yeah, McDonaldObservatory.org/eclipse. That's not hard. So thank you guys for commenting and being here. And this has been fun, even though it's not sunny. I have a giant sun right here. So I'm good. Any questions? Any answers? The map slide is so you can find the link on our resources on the eclipse page, Liz.
Do you need a special camera to shoot H alpha, or can you use your DSLR with proper filters? Thank you. You could. You would have to have a telescope with an H alpha filter. You could attach your DSLR to that telescope and get some amazing pictures. In fact, let me show you something. Let's see here. I have a good friend that lives in Indiana, and I thought I had a slide of his here ready to go in my collection of slides.
In the cornucopia?
Yeah, maybe I thought I did here. Oh yeah, here we go. Why isn't that showing up? Hold on a second. Aha! Let me show you what you could do with the proper equipment. And you saw that. Mike Borman, I've known him for many, many years, for several decades. He has all kinds of solar equipment, solar telescopes, and cameras. And in fact, this picture of his, he's had a number of pictures that have been highlighted on space weather. And so when we saw the picture of the sun earlier in hydrogen alpha, they were using a black and white camera. So he's obviously using a color camera here. Yeah, so you can get some amazing pictures, with some equipment, and it's not it's not as expensive as you think it might be, but it could get expensive. But obviously, it could very well get very expensive from that. So yeah, so that's what you can do.
Mm-hmm. And wow,
yeah,
it's good to have friends with with talents and toys. So
what else?
I think that's it.
I don't see any questions here in the chat. So
let me just say this really fast, and that is there was a solar flare happening.
Oh wow!
This afternoon.
Okay, thank you, Supernova.
From our friend Supernova. So
could have been in the picture I showed you, maybe not.
Well, it was 12:26. So
okay. I don't think that was. That wasn't a live picture that I showed you earlier. So yeah. So anything else? It's looking pretty quiet here.
That's fine.
So
everybody go look at the sun, not with your eyes.
Yeah. Thank all of you for joining us, and come out and see us. And also, we have other live streams we'll do in the future. We'll update those on our website and also the various social media platforms. So thanks a lot, and we will clear skies and keep looking up.
Yep. Thank you.
All right. Thank you.
Bye, everybody.
Bye.